All right, we got about 1 minute and 30 seconds. So um, we're gonna get started with today's lecture pretty soon. I hope you guys get a chance to maybe download the document that I shared in the text channel, so that you can either follow along or you can highlight and annotate and do whatever you want. My suggestion is to put it in, open it in an editor. You can use Office Word, Microsoft Office Word, LibreOffice Writer, or you can just upload it to Google Doc, and then you can annotate and add your own comment to the question itself. So that would be a way to take notes. All right, we got about 30 seconds to go. And we're going to start with the instructions part, which is going to be about the same for this class, with only one exception. Because last semester when I taught this class, it was not synchronous, and because this semester it is synchronous, so that means the entire class will take exam 2 at exactly the same time frame, which is kind of the same thing that we did with exam 1. Alright, so it is time to get started. The YouTube side is working already, so I'm just gonna get started here. So this is exam 2. This is the actual exam 2 of the fall semester in 2020. So I'm just going to briefly go over the instructions because excuse me, because I think it's really important to go over these instructions. Discord channels will be disabled, and if anyone has any need to clarify questions or to report an issue, you can direct message me on Discord. That will get to me a whole lot faster compared to email. This document is only for the individual with an ID of 00068887, and basically these 2 lines is to emphasize that the exam is individual, and there should be no collaboration when the exam is being taken. That's kind of the next point. But all kinds of resources are available, so online and offline resources can be used as long as there's no interaction nor collaboration involved. So that includes a lot of things. Basically, time delayed interaction is still interaction. So there's no interaction within that time frame. Do not share or discuss any part of this exam with anyone in class or otherwise on the day of the exam. So this is really kind of important because just in case somebody has a legitimate reason, so far I have not encountered that, to take the exam at a different time slot, I don't want that person to be able to know what is in the exam prior to taking the exam. So basically on the entire day when this exam happens, which is the Thursday after spring break, don't talk to anyone about this exam. The next day everything is good. Grading is based on explanation and steps, demonstration of understanding of the knowledge and problem solving skills, and not so much the final answer. So that means if somebody just gives me the final answer without following the steps, or explaining when it is requested, that answer may not get a whole lot of points. Write the answer in this document interleaved with the question. Do all your text editing in document. I have to re-emphasize this because I found at least one person so far who did a copy and paste like the entire document in exam 1. So that kind of puts me in a very, I wouldn't say difficult situation, because I really do not have a problem of saying I am not going to grade this exam because it is clearly stated that people should not be copying and pasting. So, depending, so that's basically it, right? I mean, if it is written here and somebody decides, to copy and paste for whatever reason without letting me know first, or to ask for, you know, I wouldn't say ask for permission, but ask for my opinion, um, that really is, I mean, it is what it is. So it kind of sucks. Copying and pasting means copying and pasting. You select all from one document, do a Control C to copy, go to the other document, select all, and then Control V to paste over the entire document. That is copy and paste. I have no idea whether it is copying and pasting from someone else's work, so that means any copy and paste is not supposed to happen in the exam. Because that's the whole point, right? Because if somebody just copy and paste, I cannot tell whether the copy and paste is from somebody else's work or not. And that's the whole reason why I do not want people to use copy and paste at all. With the exception of copying and pasting, non-text content. Because I know some people like to do things in a tactile way, which I can totally understand. So in that case, those people can copy and paste their own images into the document. So those are the instructions, which are about the same, if not identical to exam 1. So there we go. Now we start with a question. I kind of have to look at the other window because I know my face is at the upper right corner. That is correct. I'm just answering the question in the text channel. That is correct. I specifically said in the document here to edit in document, which means, in Google Doc, not from somewhere else. So that's do not copy and paste from an outside source, which basically refers to anything other than the document that is shared. So, okay, so now we have question number 1. So this exam is basically revolving around 2 main things. One is relations, and then the other one is resolution and CNF. So those are the 2 main topics for this particular exam. So in this particular version of the exam, I give, in each question there is a R, which is basically just a set of 2 tuples. I also define the set X, where the relation R is defined over. And now we want to find, whether it is or is not one of these, whether these qualities are true or false, given this particular relation. So I'm just going to read the entire question here. Describe relation R in the following terms. True or false, do not leave it blank. In other words, some people leave it blank because they say, oh, by default it is true. If I don't say anything, it is true. And then other people will say, by default it is false. If I don't say anything, it is false. No, we basically we have to say either true or false first. And if it is false, then we have to point out, or whoever is answering the question needs to point out why it is false. What makes a particular property false? If the answer is false, your explanation should include specific values plugged into the relation property statement that evaluates to false. Okay, so give me an example of what is failing in the quantified property statement that is actually in the notes. And you can refer to the notes in the exam because that is one of the resources that you can utilize. Well, I'm still in the process of grading exam 1. It is going a whole lot slower than I would like. For those of you who got my comments, because when I grade an exam, I would actually share it back to the person who answered the test. So as I comment on the answers, the other person can actually read my comments. So it's a very long and lengthy process because even if, somebody gave me, let's say, the first 2 or 3 answers that are completely wrong, I do not make an assumption that person is going to get the rest of the answers wrong. So I would actually go through all the variations of the questions and grade every single one, the same way, which is to look at every single part. So it does take a little bit longer. It took a lot longer, I should say, than I expected. And it's not a particularly fun process, because some of the answers are like, I'm not gonna comment too much, on some of the answers. I would just kind of say that I don't understand why certain people do not ask questions in class or during my office hour, because the answers clearly indicates that there is either a misunderstanding or something else is going on. Okay, so that's why it is kind of difficult. I cannot talk about it, before in front of everybody. But if you have any question about your individual test and how I grade it, you can certainly contact me and talk about this over office hour or something like that. All right, so enough of that. Now we want to look at this particular example, and the first question is it reflexive? So in this case, it is not reflexive. Okay, and it is not reflexive because of what? I'm gonna leave you guys to think about this a little bit, and I am going to open up a text editor just so that I can type the answer. Alright, so where is my text editor? Okay, there we go. So as you work on these answers, work on it in document. Okay, there should be no need to use Microsoft Word for this, because for the kind of answers that we put into this document, it doesn't need anything that is unique to Microsoft Word or any word processor. Notepad should be fine. Okay, so we got 2 stabs at this. Okay, one stab is there's no 0, 0, and that is correct. The other one is the lack of 2, 0, and that is incorrect. So the lack of 2, 0 does not make this not reflexive. All right, so that means, okay, so what that answer is telling me is we need to review. Not when I say we I mean you. Okay. Collectively, as a collection of students, we need to review the actual definition of reflexive and not what we think based on the word of what reflexive may suggest. Okay, so mathematics is a very precise and most of the time concise language, and the way I define reflexive in the module that talks about relation is what you need to use to find out whether something is reflexive or not, whether some relation, I should say, is reflexive or not. So in this case, the proper answer, okay, for part 1, so if I were to answer this question when asked about reflexive, I would say false. Okay, 0, 0 is not in R, or you can say 0 does not relate to itself. So both of these are acceptable explanations. Basically we use a particular example of why R is not reflexive. So are we good so far? I'm gonna go pretty slow for question number 1, and then with the other 3 questions I will go a little bit faster. But I do want to make sure everybody understand that it is not reflexive. So if somebody is to give me an answer false, but utilize the wrong example, it will still be counted as wrong. Okay, because it does not illustrate the correct understanding of what is being reflexive. In other words, 2 wrong does not make a right, but 2 rights does make a wrong, do make a wrong. I'll give you an example of why two rights make a wrong. There we go. So double positive is negative. Nah, that's just me joking in a nerdy way. Alright, so we got some questions coming. What about 1, 1 and 2, 2? So we do have 1, 1 and we do have 2, 2. So why are the presences of why is the presence of 1, 1 and 2, 2 not make R reflexive? Okay, so we need to get back to the definition. Okay, it is important to go back to the definition. And you might say, but Jack, how come you are not, going back to the definition to explain this? Because I'm assuming that you know where to find that definition. And Ivan is correct, because the key is it is using a universal quantifier. So a universal quantifier means for every element of X, that element has to relate to itself. That is the reason. Okay. Need all input from X. I'm guessing that is referring to the universal quantifier, which is the for all thing, the little inverted A thing. My face cam is blocking my notepad. Alright, I can turn off the face cam, so now I can make faces all I want. And you guys cannot see it. Ha ha. Alright, so turn that off. Come on, turn off. Okay, there we go. And of course I can move the mouse pad as well. Alright. There we go. So now I understand why students don't want to turn on their webcam, because then they can roll their eyes and make all kinds of gestures, without having to worry that the teacher might see it. Yep. Okay. I get it. All right. So it is very, very, very important to get the definitions. Now, when I say get the definitions, I'm not really just saying, oh, I know where to find the definition. That is not what I mean. I don't need you to be able to find the definition. I need you to understand the definition and be able to apply those definitions to evaluate a relation to find out whether it is of these qualities or not. Alright, so I'm going to move on to the next one, because I don't see any specific question about being reflexive, or why it is not reflexive in this way. So now we move on to symmetric. Okay, so let me move this around a little bit. There we go. And I can move the timestamp a little bit too, because I think that needs to go. I guess going up is fine, like that. Alright. There we go. Alright, so now the question is it symmetric? So when we look at this, we go like, it is not symmetric. So I think what Yolanda used as an example is now valid. False. But we cannot just say, okay, 2, 0 is not in R, is not good enough as an explanation. Because, okay, so why is 2, 0 not in R insufficient as an explanation? Well, what do you guys think? I mean, 2, 1 is missing too. Why don't I use 2, 1 is not in R to explain why R is not symmetric? So this is where you need to kind of quote the statement itself. Okay, you basically have to say x, y in R if and only if y, x is in R. Okay, and 2, 0 is in R. 2, 0 is in R Nope, the other way around. 0, 2 is in R, but 2, 2, 0 is not. That is the way that I want you to explain it. But 2, 0 is not. There we go. So let me look at the text channel. The relation R on the set A is symmetric if... So that is not entirely true. So what Ivan typed in the text channel is not entirely true, because that if should be if and only if. There's a big difference between the if versus the if and only if. Because if only goes one way, and the if and only if goes both ways. So does everybody understand what I just said? We need this thing here to be if and only if, and not just implies. Is that okay? Are there any questions about that? Okay. All right. Cool. Alrighty. So now we move on to the next one, which is anti-symmetric. Alright, so we look at this and then we ask, is this relation anti-symmetric? The answer is false. Okay, very good. And now the question is, how do we explain that? Okay, false. So now we want to go back to the definition of anti-symmetry. Okay, so anti-symmetry says AB in R and BA in R implies A equals to B. Okay. So in this case, 0, 1 is in R, 1, 0 is in R, but 1 equals to 0 is false, or 0 equals to 1. Doesn't matter which way. I mean, this is like, you can flip the order. There we go. But I want to make it this way so that you can see when A equals to 0 and B equals to 1, then the core condition inside a quantified statement becomes false. And since we can find at least one case of instantiating A and B such that this expression becomes false, then the universally quantified statement is false. Is that okay? I know I just used Greek, but does everybody understand what I just said? No, that was not Greek. That was mathematics. But same point, right? You know, does everybody understand what I just said? All right. Okay, so I'm just gonna move on if nobody says, you know, no, I don't understand what you just said. Okay, so I just move on to transitive. So now the question is, say that again. So now we move on to transitive. That's what I said. On anti-symmetry, okay. So on anti-symmetry, you have to look up the definition. The definition says for all AB in R, for all ways to instantiate A and B to elements in R. Okay, that's the better way to say it. This has to be true. AB in R and BA in R has to imply A equals to B. Okay, so that means if I can find at least one instance of instantiating A and B such that this implication is false, then it's not anti-symmetric anymore. So that's basically what I said. Okay, we're going to move on to comparable. Okay, we're going to move on to comparable, but not yet. So now we look at transitive. So now the question is this relation transitive? What do you think? All right, so it's not. Now we have to explain why that is the case. Okay, so false. What does it take for something to be transitive? So I'm gonna use the shorthand notation now because this using the in is a little bit longer. So I'm gonna say ARB and BRC implies ARC. So this is the core statement of the quantified statement. So for all ways of instantiating A, B, and C to elements of X, this implication has to be true. Okay, but in this case we have 0 R1 and 1 R. Oops, R is supposed to be capitalized because it is the name of the relation itself. Okay. Okay, I should rephrase here because now I'm using English. So we say 0 R1 and 1 R0 is true, but 0 R0 is false. In other words, I instantiate A to be 0, B to be 1, and then C to be 0 again, and then it failed the condition of this particular implication. And since I can find at least one way to instantiate A, B, and C so that the core condition is fails or it becomes false, so now the universally quantified statement itself is going to be false, and as a result, it is not transitive. All right. What if you use 2, 0, and that won't work? That is not going to work because 2, 0 is not in R. So you cannot argue to say that 0 R2 and 2 R0 because 2 R0 is false, and as a result the conjunction itself is false. What happens when the left hand side of an implication is false? What happens to the implication itself? Yeah, you cannot use that as a false argument because 2, 0 is missing. If 2, 0 is missing, then one of these two around the conjunction is going to be false. And if the conjunction itself is false, what happens to the value of the implication? Exactly, the implication becomes true. So you cannot use 2, 0 missing as the explanation of why R is not transitive. Okay, cool. All right. So as you can see, this is not the kind of exam where it can be strictly non-comprehensive because you still need to use what we talked about before exam 1 in this particular test, like the definition or the use of implication, all the set operations that we have already talked about. All of those things are still essential to answer these questions. So that's why I cannot say this test is non-comprehensive because it is implicitly comprehensive in the sense that whatever you need to work out these answers still depend on the earlier concepts that we have already asked about before in exam 1. So got to be careful about that. Okay, what about comparable? So I see quite a few text comments about comparable. So the first thing, so what do we do? Okay, so here's the question. What do we do when you see a question like this? And you go like, I have no idea what comparable means. Some people would just select, right-click, and click search, right? That probably will not work very well. So double-click, right-click, search Google for comparable. And Google will give you the actual definition of the word itself, which is not going to be very helpful. So what do? We look up the notes, right? We look up the relations module. Very good. Okay, so Jack has gotten it. Okay, we look up the relation module, And that is permissible. So don't worry about, I count that as cheating, because it is not. Okay, I think being able to look up information that existed before the exam is not cheating. Okay, because I think it's a waste of neurons to have to memorize all kinds of stuff that can easily be looked up. But that's just my view. Okay, don't quote me in your other classes. All right, there we go. So comparable is used when we need to define total ordering. So in total ordering, we say R is comparable over X if and only if, well, meaning that, is the same as if and only if, for every way to instantiate E and F as elements of X, ERF or FRE. Okay, so so applying this definition to the question, what would be the answer? So we are looking at this as the definition of whether R is comparable or not, and then we look at the exam. So is this particular relation comparable or not? And Jack is correct. It is not comparable. Okay, and let's see. Andre also typed something. ARB and BRA does not equal to 0R1 and 1R0. Okay, so when we use a, if we instantiate, so I'm getting back to Andre's text question. So when we instantiate A as 0, B as 1, and C as 0, then we have 0 R1 and 1 R0 being true. So C is 0 in this case. So I hope that answered that question. And I'm going to move on to comparable. So comparable is false. So now the question is, why is it false? Okay, why are we failing this, right? So does someone want to explain it? Because we need A, R, B, or B, R, A for every way of instantiating A, B. Okay, so how can we possibly make this false based on the R that we have? Okay, I'm gonna let you guys stare at the R a little bit to find a way so that you can say, okay, if A is this value and B is that value, then ARB or BRA is going to be false. And I think that should be, well, actually, I think I'm wrong. There's no way to make that true. No, that's one way. Yep, exactly. So Jack is right. Okay, so we can now say 0, 1 R2 is false, 2 R1 is false. So 1 R2 or 2 R1 is false, and that's why comparable is false. Or you can refer to Jack's text answer. That is correct. When we instantiate A and B, the way that he typed it in the text channel, then we find at least one way to make ARB or BRA false. But since we are using a universally quantified statement, that means if there's at least one way to make the statement itself false, then the quantified statement is false. Okay, so examples can help, but ultimately it really depends on the linking of the concepts. And Ivan is correct because 1, 2, and 2, 1 are both missing. If just one or is missing, it's okay. But if both are missing, it is not. It will make the statement false. Would it be comparable if at least one of them existed? Yes. So this entire discussion, okay, this entire discussion revolves around the understanding of, okay, I still need to find it. Okay, I got some other class stuff here. Okay, let's get rid of all that stuff here. I think it's this one. There we go. So this entire discussion revolves around this particular quantified statement, which uses really just a single disjunction, a single or. Okay. So now the question is, how do you apply the definition as it is in the notes here to the example in the question to figure out that comparable as a quality is false. All right. And Jack's question is true as well. So 0, 0 is missing also makes the relation not comparable. Yes, that is correct as well. Now, that is correct because when we look up the definition of comparable, there's nothing here that precludes E and F being the same. So if E and F are the same, then obviously if one is missing, the other one is going to be missing too. That means, then the entire OR is going to be false. So something that is not reflexive is automatically not comparable. And in this case, it is not reflexive already. We know that. So, but in the exam, you don't use that implication and say because it's not reflexive and hence it is not comparable. I still want you to explain, the using just the definition of comparable and not rely on the implication between reflexive and comparable. All right. So Evan wrote, for all values in X, they need to be somehow be related to all other values, including itself. Yes, that is correct. And then Ivan says comparable equals to every possible symmetric combination exists. No, that doesn't. Nope, nope, nope. There's nothing about symmetry in comparable because it is a simple OR. See, this is a simple OR. You can have one, you can have the other, or you can have both. You just cannot have neither. That's all. So there's nothing about symmetry regarding the definition of comparable. And then Anita wrote, if 1, 2 was a part of R but 2, 2 is missing, would that still make it false? If 2, 2 is missing, then it's not going to be comparable because if E is 2 and F is 2, then 2R2 is false, 2R2 is false, false or false is false. So now we have at least one case to make this statement false, and as a result, it is no longer comparable. So if 2, 2 is missing, it is no longer comparable, period. So I'm gonna wait for you guys to finish typing, but what I'm thinking right now in my own head was I can kind of feel there's a lack of connection, from the questions. The connection from the definition to how it is applied. So there's a lack of connection that I can kind of feel between those two, and I am not sure why. So that's a puzzle for myself to solve, to figure out, but it is nonetheless a puzzle. I think, okay, so I'm still waiting for you guys to finish typing, but I think I think, it is really kind of crucial to go back and understand what is quantification. What does it mean when I say for all EF in X, blah, blah, blah? Okay, what does that really mean? Okay, and I think I gave a code example in class, so I translate that into like a nested for loop where E goes through every single possible element and then F goes through every single possible element, and then we just say, whatever is in parentheses has to be true for every single way that E and F can get their values from the double loop. So that is the universally quantified quantifier, okay, how it works. And then what is inside the universally quantified statement, the actual statement that is quantified, is a simple OR. It really is just an OR. E, R, F is either true or false, whether E relates to F in R is either true or false. F, R, E is also either true or false. So this is just an OR. I mean, OR is one of the simpler Boolean operators. It's not implication, it's not if and only if. It simply is saying, if at least one of these two is true, then the whole thing is true. That is all that it is saying. Alright, so I'm going to go back to the text here. For all the two tuples in X, R is comparable if one or both of the two tuples exist in the relation. Yes. Sort. I mean, the actual definition is here, so every way that I used English to explain it is really a translation from the original math notation. Okay. So there we go. All right. So we are now going to move on to partial order. Partial order is going to be false because that's pretty easy, because in order for a relation to be partially ordered, it has to be reflexive, it has to be antisymmetric, and it has to be transitive. And I believe in this case, it is failing all of the above. Yep. So it fails every single thing that are all needed. So it is definitely not partially ordered. And total order requires a relation to be partially ordered to begin with, and on top of that, it has to be comparable. Oh, this one is not even partially ordered, so there's no way it's going to be totally ordered. So the explanation of partial order, the explanation why it is false, can refer back to the fact that R is not reflexive and antisymmetric and transitive. And then the explanation of why it is not totally ordered can go back to the definition of it has to be partially ordered and comparable in order to be totally ordered. And since it is not, it's not partially ordered nor comparable, so it is not totally ordered. All right, so that is one question. And of course, at the back of my mind, I'm going to have to think about how to ask the same kind of thing, but in a different way for this semester. In other words, don't count on the questions looking exactly like this in your exam too. Alright, so now we move on to question number 2. So I'm going to work out 2 of these, and then we'll move on to the other questions because I don't want to run out of time. Because the first 4 questions all have kind of the same format, so as we figure out 1 or 2, we should be able to figure out the rest. Alright, so this one is false, and why is it false? Tom is typing, and so is Jack, because 1, 1 is missing, right? 1, 1 is not in R, or you can also say 1 does not relate to 1. There we go. Is it symmetric? So, is it symmetric? Alright. Alright, so those are partially correct answers. So the full answer needs to first state false. Okay, so that is important. And then you have to quote the rule and tell me what is missing. So in order for something to be symmetric, x r y, okay, x r y if and only if y r x. So now we have to say, how we can make this fail, right? So we can now say, there are a few ways to do this. We can say 0 r1, if and only if 1 r0 is false because 0 r1 is true, but 1 r0 is false. Okay, or something to the same effect. So instead of just saying that 1 r0 is missing, we kind of have to go a little bit beyond that and explain why 1 0 is missing is causing this relation not to be symmetric. So the full answer is to say 1 0 1 is here, but 1 0 is not here, and as a result, this if and only if is false, and that is why the symmetric test fails, and the relation is not symmetric. All right, so let's take a look at antisymmetric. Is this antisymmetric? Let's see. What do you think? It is not antisymmetric, all right. And why is it not? So first of all, you have to quote the rule, right? So this part is easy if you because I do allow people to copy and paste from the same document. So you can basically just go back to question number 1 and just quote the statement that has to be true, universally. And now you have to give me an example of how you can make this statement not true. So now you can say, consider when a equals to 0, b equals to 2 makes this statement false. Yep, so Liu has gotten it. It's exactly. All right. So now we move on to transitive. Okay, transitive. All right. So is it transitive? All right. So it is not transitive. Okay, false. It is not transitive. So now the question is, how do I know it is not transitive? First thing first, copy and paste. Okay, so copy the statement that has to be true no matter how we choose A, B, and C, as long as A, B, and C are elements in X. So now the question is, how do we make this false? All right, so there are at least one way to do it. I mean, it takes a little bit of looking, but it is here. So we can say if A equals to 1, B equals to 2, and C equal to 0, okay, then we have A, R, B being true, right? Because 1, 2 is in here. Then we have B, R, C is true because 2, 0 is here. Okay, so we have A, R, B, and B, R, C is true. But when you look at ARC, it is 1 R0. So 1 R0 is false. So the implication is false, and I mean, you can stop here. Okay, if you can say that this implication is false, that means it is no longer transitive. So we are good here. All right. So it looks like we got some typing, some stuff coming in through the text channel. yes, it is because 1, 0 does not exist, but it's not only because 1, 0 does not exist. It is because 1, 2 exists, 2, 0 exists, but 1, 0 does not. So, in other words, if I just see the answer of 1, 0 is missing, I cannot give a whole lot of points to that answer, okay? Because it doesn't tell me the rest of the story, okay? Why 1, 0 being missing is causing this relation not to be transitive. It doesn't really answer the question. It just says, hey, if you, this is, I mean, it really doesn't answer the question. To answer the question, we have to point out what else is causing this relation not to be transitive. Okay, all right. So let's look at comparable. So that is an easy one, okay? Because we already know it is not reflexive. So now we can say it is not comparable, but not because it is not reflexive. We just utilize 1, 1 as an explanation, but the actual logic is different, okay? Because in order for it to be comparable, we say false, and then once again we copy and paste, right? So we just copy and paste from here. Okay. Okay, why is it on a new line? There we go. So we say, this has to be true for every way of finding, A and B. So now we say, if A equals to 1, B equals to 1, makes this disjunction false. There we go. So the explanation is different because in order to explain why it is not reflexive, it really is just, okay, as simple as 1, 1 is not in R. Okay, that fully explains why it is not reflexive. But to explain why it is not comparable, it is because it makes this disjunction false. So that's a different explanation, cannot be as simple as the explanation in reflexive. Alright, so moving on to partial order. Partially ordered has got to be false because it is not reflexive, it is not antisymmetric, and it is not transitive. The 3 requirements in a conjunction that we need for partial order, they're all missing. So that's why it is not partially ordered, because reflexive and antisymmetric and transitive is false. Now we get to totally ordered. Okay, this is also false because partially ordered and comparable is false. There we go. Alright, so as I said a little bit earlier, I'm going to move on to, I'm going to skip the next 2 questions because, according to this instruction here, the next 4 questions are very similar. So I'm going to skip the next 2 and get on to question number 5. So question number 5 and 6 are very similar. I might pick just one of them because I want to get to at least one of the other questions, 7, 8, and 9, and 10. So we'll work on one of these 2. Okay. Alright, so question number 5 is kind of the reverse of the first bunch of questions. Okay, 5 and 6 both have the same kind of format. Because this time I want to spell out a certain combination of qualities, and then you have to come up with an example or to say it is not possible. Okay, so this is the opposite. So we are no longer given a relation and just to evaluate it. Now we have to define an actual relation so that it meets certain requirements. Alright, so let's go for question number 5. So question number 5 says it is not reflexive, not antisymmetric, it is transitive, it is comparable, and it is symmetric. If no such R exists, explain using the quantified qualifying statement of relation properties why that is the case. There should be a conflict somewhere if such an R does not exist. So you have to explain to me where the conflict is, why all of those qualities cannot exist at the same time. Alright, so we already know X is given, which is 0, 1, 2. So now we have to find an R to meet all of these requirements, and if it is not possible, then we have to say why it is not possible. Okay, so I can see that there are some text coming in, but before I can see any text, I'm gonna focus on this one. Alright, so we do want this to be comparable, and we also want it to be symmetric. That alone, or I should say, just because it has to be comparable, means it has to be reflexive. And as a result, it is not possible for something not to be reflexive and comparable at the same time. So now we can just explain and say, if a relation is comparable, it is reflexive as well, because in order for ARA or ARA to be true, this is going to sound really kind of stupid, but it's not. ARA must be true. There we go. So that is sufficient as an explanation. Oh, relation, that's right. Okay, so I'm getting back to the text channel. If symmetric is true, is comparable always false? No. You can have both. You can have those two being true at the same time. And then Jack says, I am thinking of reflexive. Oh, okay, not me, but Liu. Okay, that's right. Okay. All right. All right, so is this explanation okay? Does everybody understand why? The rationale, if a not resolution. Okay, now I understand why Aiden said that. Why a relation? Okay, if a relation is comparable, it is reflexive as well, because in order for it to be comparable, this has to be true, for all the elements A that we find in X. But if in order for this disjunction to be true, ARA itself has to be true. So if ARA is true for every way to find, to bind A to a particular element in X, sorry, then it is automatically reflexive. But if you explain only this part, I would take it as a correct answer. All right. So since number 5 is such an easy one, we'll move on to question number 6, because I do want to show one that is possibly a little bit more complex. All right, so here's question number 6. So question number 6 wants it to be reflexive. It wants it to be anti-symmetric. It wants it to be not transitive. It is comparable and not symmetric. So the question is, is it possible? If it is possible, give me an example. And if it is not possible, tell me why it is not possible. All right. So let's think about this. Okay. So I don't know the answer. You guys may think, but Tack, surely you have the key to this particular question. Yes, I actually do have the key, but I haven't looked at it yet. Okay. So I want to work on this one, just because I want to show you how to reason this out. Okay, so because in order for something to be reflexive, these 3 must be in the relation already. Oh, you guys want to think about it? Okay, sure, go ahead. I'm gonna think about it myself too. Let me know when you guys are done thinking. This is the problem of your professor not being a mind reader. And not just not a mind reader, it's not being a mind reader over the internet. and Darth Vader can force choke over the internet. Yep, Jack is right. Okay, so Jack is right. So the way we look at this is to say, what is the minimal thing that we need to do for it to be oh, which one? Oh, number 6, that's right. So what is the minimal thing that we need to do to make it anti-symmetric? And the answer is nothing. The empty relation is already anti-symmetric to begin with. Okay, so that is kind of cool. What about is not transitive? So in order for something not to be transitive, we just have to find or construct one single case where ARB is true, BRC is true, but ARC is not true. Okay, and that can be arranged by flipping something, right? So that instead of having ARC, we have CRA. We need that because we also want it to be comparable. So that's why. So that's kind of the way that I think. And not symmetric is easy. Okay, you just have one but not the other. That makes it not symmetric. Okay. So depending on how you construct this, I can say, let's put 0, 1 here. Let's put 1, 2 here. And then 0 also has to relate to 2, but I cannot have 0, 2 because that would make it transitive. This will make it not transitive. Okay, so I have met most of the requirements. It is reflexive, it is anti-symmetric, it is not transitive. So now I just have to check whether it is comparable or not. 0 relates to 0, 0 relates to 1, 0 relates to 2, or 2 relates to 0. We're good there. 1 relates to 1, 1 relates to 2. We're good there. 2 relates to 2. So now this is the answer. That should work. I'm looking at the text channel. 0, 0, 1, 1, 2, 2, 0, 1, 0, 2, and 1, 2. So Ivan's initial answer doesn't work because because that one is actually transitive. So you just have to flip those two to make it not transitive. There we go. Cool. Ugh. So I can't really say or demonstrate any more about how I came up with this solution other than what I just said. Okay, it's really just constructing it step by step, looking at the requirements and not to put in something unless it is necessary, right? And the one that would put in the most items, being reflexive, basically says yes, those specific items has to be there. And then being comparable also means, oh, okay, we better make sure that everything relates to everything. Okay, the direction is not important, but we got to make sure everything relates to everything. So after those two requirements, then we just have to make sure that it is anti-symmetric, which is easy to do because if it is not symmetric, it is already well, I shouldn't say when it's not symmetric, it is automatically anti-symmetric, but there is a correlation between anti-symmetric and symmetric. Okay, it's hard for me to explain it, but there's a particular way that those two are related, but it's not, if one is true, the other one cannot. It's just that there's a correlation. Okay, that's all I can say. And that's it. Okay, so that's the answer to question number 6. So now we move on to questions 7, 8, 9, and 10 and see how many we can solve for today. So 7, 8, 9, 10, they are all resolution and CNF kind of question. So given that psi represents everything known to be true and psi is this particular statement and phi is a proposed theorem and phi is blah blah blah, use CNF, resolution, and proof by contradiction to conclude whether phi is a theorem or not. Be sure to include and explain all the steps involved. Okay. Well, reflexive is compatible with both anti-symmetry and symmetry, but one does not lead to the other. Okay, so getting back to question number 7, so the first thing we need to do is to convert something into CNF. So this is the one that we just do a conversion because it is everything that is known to be true at this point. So now we look at this and convert it into a CNF. Alright, so the first thing I do is to get rid of the implication. So this implication is applied to, this is the entire, let's see, left-hand side of the implication. So that whole thing has to be inverted. Okay, so not inverted, negated, I should say, negated. So we just add a negation to this entire thing, and I just stack, parentheses, and then we have an or, and then the other side stays the same as usual. So now what we do is we simplify, right? Because we have a negation on top of a negation, so they cancel out. So now we just have not P, not Q, or not R, not Q. And that is not in CNF. This is in DNF. It is in the disjunctive normal form. So one quick way to turn this into CNF is to FOIL. Okay, so we just do a FOIL. So when we FOIL this, we end up with 4 terms. And then those 4 terms, we basically, it's kind of like a Cartesian product, right? So we got a not P or not R, not P or not Q. Oops. Not P or not Q, and then we have not Q or not R, and then we have a not Q or not Q. There we go. And then after the FOIL, we just kind of work it out and see if there anything we can simplify. And as it turns out, so this is why I really like using an editor, because I can copy and paste. So we can just say, we can simplify that. But once we simplify that and everything is now in a conjunction, we can now say, if something is more specific than some other things, we just keep the more specific item. So that means this one can go. So that one goes away, and so can this one. So both of those goes away, and we just end up with this particular CNF. So that's step 1. And then we look at phi. So phi looks kind of ugly. Okay. So now we look at phi equals to blah, and not phi. Remember to invert it first, or negate it first. So phi is the proposed theorem, which needs to be negated first before we turn it into a CNF. And we just kind of do this step by step. Alright, so first step is to get rid of the implication. Alright, so copy and paste, and then we get rid of the implication. So the implication becomes a OR, where the entire left-hand side, which is here, is negated. So fortunately, in this case, we can just put a negation over here. And I got some text activities here. Why did the other 2 go away? Because of the simplification rule that I already mentioned for the homework assignment. The simplification law rule basically says, A or B, and A is just A. That's the simplification that we used. Exactly what Jack says. Alright, so now we look at this and go like, can we cancel out the double negation? The answer is no, we cannot cancel out the double negation. Can we cancel out the double negation? The answer is no, there's no double negation. In other words, there is no double negation at this point, okay? Because the negation here, that applies to this OR. This negation, on the other hand, applies to these ors. Okay, so there's no actual negation that applies to another negation directly. So we cannot cancel out negation like just like what I said. So what we do is we apply De Morgan's law instead. So now we copy and paste, and we look at this and go like, okay, let's work with this one first. We apply De Morgan's law. So De Morgan's law basically says, let's distribute this negation to everything inside the original OR, but then all of these things that were ORs that will now become ANDs. Okay, and might as well do the other one too, right? Same thing, De Morgan's law. So we distribute this not to the inside of the disjunction, but then the disjunction has to be turned into a conjunction, like that. Alright, so now we look at this and go like, okay, let's do some simplifications. Actually, the better way to do this is to copy and paste, and then only make changes where it is applicable. So the only thing we do is just to get rid of the double negation. And now we look at this and go, okay, so now we got another text here. Couldn't you apply the outside negation first and make my life easier by canceling the inside two negations? Yeah, sure. There are many ways to do it. Yep, but since I'm already down the scenic route, we'll just do the scenic route. Okay, so now we can apply the De Morgan's law to distribute this negation to the inside. So we distribute this negation to this guy and also this guy, and then we turn this OR into an AND, like so. And now we look at this and go like, what do we do now? Oh, okay. So now we look at this and we go like, is this in CNF? No, it is not in CNF, because this negation here is not applied directly to a single variable. It is applied to a disjunction. And the same thing applies to this negation here. It is also applied to a conjunction. Okay, so now we need to apply De Morgan's law, right? So when we apply De Morgan's law, okay, so I'm gonna copy and paste, right? So copy and paste is nice in the way that you can, it's easier for you to track, what has changed. Okay, so now we distribute this negation to this, and also to this, but all the conjunctions now become disjunctions, just like that. And then we now distribute this negation to the inside of the conjunction. So we can distribute this to here and also here, but then the original conjunction now becomes a disjunction. Okay, that looks really awful, right? That's okay, because now we apply some simplifications. Every time we see exclamation point, we just say, nah, that's not needed. That's not needed. There we go. And now we look at this and go like, can we do something like with what we did before and simplify another step? The answer is no, we cannot, because we can only do that if this was not the negation of P, then we could do the same trick. But since this is the negation of P, it is no longer matching P or Q, so we cannot apply that simplification anymore. But this itself is CNF. It is a conjunction of disjunctive terms, so we are good here. We are not resolving because the distinct steps of what I want is to have psi converted into a CNF, have not phi, which is what we're doing right now, converted to a CNF, and then we make a super CNF before we start to use resolution. So we are not resolving, at this point. Okay. So now we basically combine the two. So we have psi and not phi being. So once again, it is kind of handy to be able to copy and paste, because now we just copy and paste, and then we have another copy and paste over here. So we have copy and paste over here. Alright, so now we look at this and go like, okay, what can we do to resolve this? Okay, there's so many choices, right? I mean, there are so many choices. So I personally prefer to kind of do it more systematically. So we look at the not P over here, and there's a P over here, and now they can resolve. So once again, when you perform resolution, this is also something that was really hard to read when people don't copy and paste the entire thing and then just add the result of resolution. Okay, so in this case, P, Q, R, so Q goes first, Q or not R. So this is the product of applying resolution, but now it becomes a part of the super CNF. So now we look at this and go like, okay, so I think we are done over there, but guess what? R can be used as a connection to do one step of resolution. So we copy and paste, and the new term that we are creating is going to have not P or not P or Q. There we go, which simplifies to just not P or Q. Okay, let me look at the text channel. Okay. Alright, so now we look at this even longer CNF, super CNF, and ask, okay, is there any other way for us to do resolution? And the answer is no, I think we got it. Well, we got it for the first term. So now we move on to the second term, which is not Q. Not Q has quite a few places where you can resolve, right? So the first place is this place here. And we kind of have to make sure that the result of the resolution is something that is new, something that we haven't seen before. Because if we can only regenerate the same term over and over again, we're done. Alright, so in this case, not Q disappears entirely, then we have just not P or R. Okay, so that becomes the new term that we generate. And then we look at this not P and go like, hey, we got a few more places that we can go, like here and here. Okay, so this is an easier one because we just end up with P all by itself, right? So now we have just P by itself. And then we look at this not Q. I mean, if you can spot, a quick and easy way to get to a contradiction, you can just go straight right to it. Okay, I'm not going to fault anyone for choosing not to go for the scenic route, especially when you're in the exam and your time is precious. So if you don't want to go for the scenic route, don't go for the scenic route. All right. So anything else? Yep. There's another one. So this not Q can also resolve with this Q here. And this is the one that is super duper helpful because now even I can see there's a resolution. There's a contradiction after this because now we have not P left all by itself. And then looking at this and go like, okay, I think I'm done, doing stuff systematically. I can just say, here's a P and here's a not P. And when they resolve, we get false. Okay? So now, finally, we can say, since the negated theorem negated phi results in a contradiction, phi is a theorem. There we go. Or something to that effect. Just kind of explain to me what is your conclusion and why you arrive to that conclusion. Okay, so that's question number 7. It depends on what you mean by not going step by step. Where are you not going step by step? It's not CHF, it is CNF, conjunctive normal form. It is not a conjunctive hyperform. Well, when you are resolving, if you can find a shorter route to get to the contradiction using resolution, you can go ahead and use the shorter route to get to the contradiction. But this part here cannot use. Oh, there we go. I think my computer just locked up for a moment, and it is back. Okay, there we go. Let me just go back to say what I said. For this portion, in terms of resolution, you can shortcut. If you can eyeball and go like, oh, I have a much quicker way to get to the contradiction, go for it, okay? But it still needs to be step by step. You cannot just go like, oh, I can see how this can resolve to false and then just just append the 0 at the end of it. That won't work, okay? And then for the earlier part, okay, which is converting into CNF, for this part here, if you skip steps and you make a mistake, I cannot give partial credit because I can just go like, nope, these things are not connected. So I would still go step by step as much as possible with these steps here because it's not really taking any much more time with these. I mean, I personally, if I were taking this test, I would go step by step because this way the chances of me making a mistake would be smaller. So that would be my answer to the question of am I okay with not going step by step? You can combine certain steps. I mean, if you want to combine, like in this case, I did skip a step because when I went from this line to this line here, I basically applied the Morgan's law to both sides of the OR. So I didn't separate and say, okay, let's work on the left-hand side first, and then we work on the right-hand side, because those two are fairly independent. So I personally feel comfortable with, like not separating those into two individual steps. But if I were to jump, from say the first line all the way to this line here, that would be too much of a jump. All right. So more questions. What would be an acceptable final answer for question 7 to 9 if resolution does not work out? So if the resolution does not work out, then you will get to a certain point, okay, where any further resolution would just produce exactly the same term over and over again. So at that point, you can basically start to make a conclusion and say, this is a dead end. No further resolution is possible, and as a result, phi is not a theorem. So that's how I would phrase it. But you'd better make sure that there are no further resolution possible. So I don't want someone to basically get to a certain point, let's say here, and go, okay, I cannot see any further resolution, and as a result, phi is not a theorem. Because in this case, I can definitely see there are more things that we can produce using resolution, and as a result, stopping here is not going to count as a good answer. Okay. And then Liu said, I'm worrying whether there will be enough time for the exam. I know you guys won't like this answer. Just do your best. And then Angel said, is a good rule of thumb to just try and resolve every term from psi. Not from psi so much. It is the super CNF. So you have to combine psi as a CNF and also not phi as a CNF. So that concatenation of CNFs, that is where you need to perform the resolution. And then Aiden said, do we have to use resolution to do P not P being false? Technically, yes. Technically, yes. All right. So, all right. So I know it's not going to help, but it's not going to help for most people, I should say. But in my mind, when I was a student, it helped me. Don't worry too much because worrying is not going to help, right? So what we need to do is not to worry and instead use that energy to understand the material. And so it's not really just reading, it's not just reading, it's not just watching the video again, but to really understand what it means. What do the definitions mean? So start with the definitions. Okay, you might want to. Yeah, I'm not going to take roll today, Dawood. We're good for today. So start with the definitions. Okay, compile a list of all the definitions. On with your own list. And then you want to look at the mathematical definitions and really understand what it means. Okay, what does it mean when we have a universal quantifier? What does it mean when I say implies? Okay, what does it mean when I say if and only if? Do you know the truth tables of all of those Boolean operators? Okay, do you understand what A, R, B means when A and B are from the set X? Okay, how does that correlate to elements in R as a set of two tuples? Okay, do you understand all of the rules in Boolean algebra? Okay, how to do simplification, De Morgan's law, and so on. So start with those, okay, because you got to have a foundation, a solid foundation of all of the basic stuff first before you can apply those foundational concepts to solve a problem, which is what the questions of the exam will appear. All right. So I still have office hours. Okay, I still have office hours every day for the rest of this week until Friday, and then the spring break is supposed to start on this Saturday. So that means my turnaround time, officially according to the syllabus, would go to 48 hours, during the spring break, and then back to within 24 hours on the Monday after spring break. So I typically would get to the questions a little bit sooner than 24 hours or 48 hours, but there's no guarantee, of that, of me getting to the questions as early as possible. All right. So the exam is going to be the Wednesday after spring break, not the Monday. So that's good, okay? It is good because as you think about these things, over spring break, and you go like, I'm not quite getting blah blah, okay? So that means you can still use the Monday after spring break to ask further questions before we have the actual exam on the Wednesday after spring break. Well, Monday cannot start technically without a lot of coffee. So there we go. All right. So unless there are questions that I need to answer while streaming, I'm going to stop the stream at this point. I'm not going to give you the assignment because at first, I was thinking about giving you an assignment where you have to generate, combinations or permutations. So we are not going to do that. Okay, we're not going to do that until probably after the exam, because I want you guys to kind of focus your energy to prepare for the exam. It's not so much studying. I really don't know what it means when people say I need to study for the exam. In this class, it is all about understanding the material to the point that you can apply the material to solve problems. So that's kind of what people need to do. So make sure that you look at everything and ask yourself, whether you fully understand that concept or not. So you can know that you don't fully understand something. Okay, this is the clue. Okay, this is kind of how I think. So I know I'm not really understanding something when I can come up with several ways of interpreting something. So I can say, if I read this sentence, this can be true, or this can be true, or this can be true. But I know one of them, is actually true. The other two has to be false. So that tells me that I'm not fully understanding something. And that's kind of my thought process. I'm not really sure whether it is applicable to you or not. I'm just explaining how I process, material when I was a student. All right, cool. I'm gonna shut up and stop streaming now. You guys have a nice weekend and a spring break. I know, it's not a good feeling that there's an exam right after spring break, but this is not one of those things where you have to kind of memorize a lot of stuff. I mean, sure, there's a little bit of preparation, right? You basically get all the definitions to one place, make sure you know where to find the stuff. But it's not so much that you have to read and memorize a lot of things. It's more like, you read something and you fully understand exactly what it means. And that is the important part. Oh, you guys are welcome. I'm just, spewing stuff. That's all. All right, cool. You guys have a nice break. And if you need to contact me, Discord is the quickest way to get to me. And I will still answer questions over the break. So in case you guys have any questions. All right, there you go. Yep. See you Monday after next. There we go.